Yes, typically pole owners are responsible for pole condition and maintenance. The dense vines climbing the pole and guy wires pose a significant safety hazard due to the potential for electrical conductivity. The vines can accumulate moisture, creating a conductive pathway for electricity. When combined with the heavy weight of the vines and ice, this can increase the risk of electrical shock and falling hazards. When a person working on the pole touches the vine-covered surface, they can come into contact with electrical current flowing through the vines. This can cause an electrical shock and lead to serious injuries, as was the case in the situation described. The voltage carried by the vines depends on several factors, including the type of vine, the moisture content, and the voltage of the electrical lines on the pole. However, it is difficult to provide an exact estimate without specific measurements. It is important to note that even a small amount of voltage can be dangerous and cause harm. In most cases, the pole owner is responsible for maintaining the safety and structural integrity of the pole and its associated equipment, including guy wires. This includes ensuring that the pole is free of any hazards that could compromise its stability or pose a risk to workers. Therefore, the pole owner would likely be responsible for addressing the overgrown vines and ensuring that the pole meets safety standards. Electrical safety is paramount when working near power lines and equipment. Vegetation, such as vines, can create unexpected conductive paths, increasing the risk of electrical shock. The presence of moisture, from rain or ice, further enhances the conductivity of these vines. The voltage present on a vine-covered pole is not a fixed value, but rather a variable quantity that depends on several interrelated factors. Firstly, the voltage of the electrical lines themselves is a primary determinant. Transmission lines carry significantly higher voltages than distribution lines, and service drops carry the lowest voltages. Secondly, the type of contact between the vines and the energized components plays a critical role. Direct contact with a high voltage conductor will result in a much higher voltage on the vines compared to indirect contact or proximity. Thirdly, the type of vine is important. Some vines have higher moisture content and more conductive properties than others. Fourthly, the moisture content of the vines themselves is a crucial factor. Wet vines are far more conductive than dry vines, significantly increasing the risk of electrical shock. Fifthly, the presence of contaminants such as dirt, pollutants, or salt on the vines can further enhance their conductivity. Sixthly, the distance from the energized source is another factor. The voltage on the vines will typically decrease with increasing distance from the point of contact. Seventhly, the grounding of the pole and associated hardware can influence the voltage on the vines. A properly grounded pole will help to dissipate any stray voltage, reducing the risk of shock. Due to these variables, it is nearly impossible to provide a precise voltage estimate without on-site measurements using specialized equipment. However, it is crucial to understand that even a relatively low voltage can be dangerous, especially in wet conditions. The human body's resistance to electrical current varies depending on factors such as skin dryness and contact area. A small current, measured in milliamperes, can be enough to cause muscle contractions, burns, or even cardiac arrest. Therefore, it is imperative to treat all vegetation near electrical equipment as potentially energized and to maintain a safe distance. Utility companies employ various methods to manage vegetation around power lines, including trimming, removal, and the application of herbicides. These measures are essential for preventing electrical hazards, maintaining system reliability, and ensuring public safety. Workers who are required to work near power lines must receive thorough training on electrical safety practices, including the proper use of personal protective equipment and the recognition of potential hazards. Furthermore, it is essential to report any overgrown vegetation or other potential safety hazards to the utility company promptly. Ignoring such issues can have serious consequences, as demonstrated by the incident described, where a technician was injured due to contact with energized vines. Regular inspections of utility poles and equipment are crucial for identifying and addressing potential hazards before they lead to accidents. These inspections should include a thorough assessment of vegetation growth, the condition of the pole and hardware, and the effectiveness of grounding systems. Any deficiency should be promptly corrected to maintain the safety and reliability of the electrical system. The National Electrical Safety Code, or NESC, provides guidelines for vegetation management around power lines and other electrical equipment. These guidelines specify minimum clearances between vegetation and energized conductors, as well as requirements for inspection and maintenance. Compliance with the NESC is essential for ensuring electrical safety and preventing accidents. Furthermore, local regulations and utility company policies may impose additional requirements for vegetation management. It is important to be aware of and comply with all applicable regulations and policies. The use of non-conductive tools and equipment is essential when working near power lines. Tools such as fiberglass ladders and insulated gloves can help to protect workers from electrical shock. However, it is crucial to inspect these tools regularly to ensure that they are in good condition and free from defects. Even with the use of protective equipment, it is important to maintain a safe distance from energized conductors. The minimum safe distance varies depending on the voltage of the power lines. Consult with your utility company or a qualified electrical safety expert to determine the appropriate safe distance for your specific situation. In addition to vegetation management, proper grounding is essential for electrical safety. Grounding provides a path for fault current to flow back to the source, helping to protect equipment and prevent electrical shock. Utility poles are typically grounded using a grounding electrode, such as a ground rod or a buried ground wire. The grounding electrode should be properly sized and installed to ensure that it provides adequate grounding protection. Regular testing of grounding systems is essential for verifying their effectiveness. Ground resistance measurements can be used to assess the condition of the grounding electrode and the overall grounding system. Any deficiencies should be promptly corrected to maintain the integrity of the grounding system. Furthermore, surge protection devices can help to protect equipment from voltage surges caused by lightning or other events. Surge protection devices divert excess voltage to ground, preventing it from damaging sensitive electronic equipment. These devices are typically installed at the service entrance of a building or at individual equipment locations. Regular inspection and maintenance of surge protection devices are essential for ensuring that they are functioning properly. The electrical grid is a complex and interconnected system, and maintaining its safety and reliability requires a collaborative effort from utility companies, contractors, and the public. By understanding the potential hazards associated with electricity and following established safety practices, we can all help to prevent accidents and ensure a safe working environment. Moreover, educating the public about electrical safety is crucial for preventing accidents involving power lines and other electrical equipment. Utility companies often conduct public awareness campaigns to educate people about the dangers of contact with power lines and the importance of staying away from downed wires. These campaigns may include educational materials, public service announcements, and community outreach events. The topic of electrical safety is important and requires constant attention. All workers need to know how to stay safe on the job. There are various resources available to workers to provide them with knowledge and skills in order to keep them safe. Firstly, OSHA, which stands for Occupational Safety and Health Administration, is a federal agency responsible for ensuring safe and healthful working conditions for workers by setting and enforcing standards and by providing training, outreach, education, and assistance. Secondly, the National Institute for Occupational Safety and Health, also known as NIOSH, is a federal agency responsible for conducting research and making recommendations for the prevention of work-related injury and illness. Thirdly, the National Safety Council, also known as NSC, is a non-profit organization that provides safety training, education, and advocacy. Fourthly, the Electrical Safety Foundation International, which is SV, is a non-profit organization dedicated exclusively to promoting electrical safety at home and in the workplace. Fifthly, your employer has a responsibility to provide you with electrical safety training and personal protective equipment. Sixthly, your local utility company can provide you with information on electrical safety in your area. Seventhly, trade unions and professional associations offer electrical safety training courses and certifications. Eighthly, community colleges and technical schools provide courses on electrical safety and related topics. When working around electrical equipment, it is important to be aware of the potential hazards and to take the necessary precautions to protect yourself from electrical shock. Always assume that electrical equipment is energized unless it has been properly de-energized and locked out. Maintain a safe distance from energized conductors and equipment. Use personal protective equipment, such as insulated gloves and safety glasses, when working with electrical equipment. Never touch electrical equipment with wet hands or while standing in water. Report any electrical hazards to your supervisor or utility company. By following these safety tips, you can help to prevent electrical accidents and ensure a safe working environment. Remember, electrical safety is everyone's responsibility.